Hello everyone, this is Dr. Shawn Cruzen from Columbus State University's Coca-Cola Space Science Center, and well, that's exactly where I am right now. I'm inside the Space Science Center, and welcome to our virtual tour of our exhibit gallery. We're going to take you through and we're going to show you some of the amazing artifacts from the Space Shuttle program and the Apollo program that we have on display here inside our exhibit gallery at the Columbus State University Coca-Cola Space Science Center. Now, first of all, I would like to just say, this is different for us, right? We're all in this different mode. Lots of interesting things are happening. This is going to be a really kind of informal tour. And so, if our camera droops or, if I drop something, it's just because it's real time and live and interactive, right? So what we're going to do also is we're going to have your questions at the end of our tour. And so several of you have sent in questions to us, and we're going to address those questions at the end of our tour. All right. So now, what I would really like to do, I would like to focus in on some of the really cool stories that are associated with some of our exhibits right here in our exhibit gallery that have to do with this amazing spacecraft called the Space Shuttle. Now listen, the first thing I'd like to do is just tell you a little bit about the Space Shuttle itself. Space Shuttle was, well, you know what? It was like a semi-truck. It quit flying in 2011. It began in the year 1981. So for 30 years, this was our 18-wheeler hauling cargo to space. And the reason I say that is because even the structure of the Space Shuttle was very much like an 18-wheeler. If you take off the big orange fuel tank and the booster rockets that help get it to space, and you simply focus on the orbiter itself, the orbiter itself has two very important components. One, it has what's called the crew cab up here in front. That's where the people actually sat when they flew in the Space Shuttle. And then all this room in the back was a giant cargo area. Now this is where they could really pack in the equipment to take it up to space. What went to space in the back of here? Some amazing research satellites, very important communication satellites, really important military satellites. The Hubble Space Telescope rode to space in the cargo bay of the Space Shuttle, and also so did all the pieces of the International Space Station. And they connected them like Legos, and now that thing's the size of a football field. So that's the way it got to space, is in the back side of the Space Shuttle. So the Space Shuttle was really big. In fact, you could take a school bus and sit it inside that cargo bay, and the whole school bus would fit inside the cargo bay of the Space Shuttle. So we could really haul very large payloads to outer space. But there was another side of that. If the Space Shuttle was that big, how big was that fuel tank? Well, that orange fuel tank right there was an 11-story fuel tank. And then on either side are some 10-story solid rocket boosters. In other words, the size of 10-story buildings, 10 floors high. Those were all full of things that really like to burn, or maybe even would like to explode. So on the launch pad, if you strap that tank, that fuel tank and all those booster rockets to the Space Shuttle, and you had all your payload in the back, and these people were sitting up in the front, and it's sitting there ready to launch to outer space. Well, quite frankly, ladies and gentlemen, those folks were sitting on a very large, potentially explosive device. Now here's the question. If you're sitting on this big thing and something could go wrong, you could have a fuel leak, or you could have some kind of a fire and you had to get out fast, what would you do? Remember that once you add the launch pad underneath, the astronauts themselves are 200 feet in the air. Well, what I'm going to do now is I'm going to start our walk through our exhibit gallery, and I'm going to walk you over to one of our artifacts that was made specifically to help people get off that launch pad in case there was an accident. Come on over here with me. Let's check this out. What I'd like to show you is this particular escape basket right here. Imagine you and at least 3 of your best friends on the inside of that basket right there, right? So you're standing inside this basket, dangling from 200 feet in the air. The Space Shuttle has a fuel leak going on behind you, or maybe even a fire, and it could blow up any second. What do? Well, you hit a big lever with your hand, and then that whole basket would slide down a giant zip line from the top of that launch tower all the way down to the ground, 200 feet in the air. Now the thing is, when you're that high and you're sliding down a wire, you're going to get going fast. The top speed on this basket was 55 miles an hour. There are no brakes. There are no airbags. There's no seat belts. it's kind of a dangerous proposition. This basket is actually made of canvas covering steel. So there's not a whole lot of safety features in the basket. So it was only in the most dangerous of times that astronauts ever would use this, or technicians who might happen to be up on the tower. In fact, they had to test this basket twice a year. And because of that, they only tested it with sandbags. They would put sandbags in this basket and let the sandbags slide down just to make sure the basket was working. However, one day, they finally allowed an astronaut to ride this basket to the ground. The first astronaut to ever ride this basket to the ground, that astronaut's name was Charles Bolden. Charles Bolden was a two-time Marine Corps fighter pilot. Charles Bolden had been to space he was a Marine Corps fighter pilot and a two-time space shuttle flyer. That's what I meant to say. He'd been to space on the shuttle 2 times after being a Marine Corps fighter pilot. So he had experience both in aviation and in outer space. And they finally said, Charles, we really need to let a person test this basket. Would you be willing to jump in here and let us slide you to the ground? Well, Charles Bolden was a brave guy, and so he did that. He slid down to the ground, he made it safely. He said that was one heck of a ride. But the interesting thing about that is, later on, Charles Bolden went on to be the director of all of NASA. So apparently, if you want to be the big boss at NASA, you got to ride the basket to the ground. Now, ladies and gentlemen, this is not a replica. This is an actual basket from Launch Pad 39A at the Kennedy Space Center that hung up on that tower to assist those astronauts off in case of an emergency for the entire 30-year history of the Space Shuttle program. We're very excited to have it here in the gallery of the Space Science Center. Slide on down here with me. I got some more cool things to show you. Come on down. Check these out. These look at first glance like just a couple of old desks. And they sort of are just a couple of old desks. But not just, because these are very special desks. These consoles came out of what's called the firing room at Kennedy Space Center. In other words, it's the room where the technicians push the buttons to launch the astronauts to space. And then they monitor all the systems and all of the things that had to work just right in order for those astronauts to get to orbit. Now, the interesting thing is this console right here. This is a unique one. This is where the flight surgeons sat. In firing room number 3 at the Launch Control Complex at the Kennedy Space Center. What are flight surgeons? Well, they're doctors. So why do you have doctors at a launch site? Well, it turns out that the pilot and the mission commander, they were the 2 people actually flying the space shuttle. Everybody else on board, they're a little bit like cargo. But just for the flight up, they have to monitor the health of those 2 very important astronauts because they're the ones who are actually flying the vehicle. So the doctors who are on the ground sitting at this console were watching their heart rate, their blood pressure, their oxygen content, to make sure they were breathing properly, make sure they weren't about to pass out. All of those things could make them put a stop on the mission before it ever went to space. Now, the very interesting thing is the flight surgeons were sitting at that very console behind me the very first time the space shuttle ever went to space. John Young, a Georgia Tech graduate, by the way, John Young and Bob Crippen were the first 2 astronauts to ever fly the space shuttle into outer space. No one had ever flown this launch vehicle before. It was sitting on the ground ready to launch. The flight surgeons were monitoring the vital signs of those astronauts. And all of a sudden, Bob Crippen, who was the pilot, he's like the co-pilot on an airplane. He's the number 2 guy. His vital signs started to climb up. His breathing got a little shallow, a little bit more rapid. His heart rate increased. His oxygen content level fell. And they were radioing in saying, "Hey, Bob, you doing okay?" Well, Bob Crippen was nervous, as you can imagine. This is the first time anybody had flown this spacecraft to space. They didn't know if it was going to work. And then they looked at John Young. John Young was the mission commander, means he's the number 1 guy. He's the main pilot, right? He's sitting in the seat next to Bob Crippen. And, well, the flight surgeons told me personally, it looked as if he was sitting on his couch on a Sunday afternoon, having a lemonade. Because his vital signs were perfectly normal, his breathing was just perfectly normal, his heart rate was great, his oxygen content was high, and they said, "Hey, it looks like John Young's got this." So Bob Crippen, John Young, the first 2 astronauts to ever fly to space, the health of those astronauts monitored from this very console. One last story, which this is just really cool to me. We were the first museum anywhere in America that was allowed to take consoles from the firing room at Kennedy Space Center and put them on display. That makes us a very special museum. And I'm super excited to be able to have these consoles on display for all of our visitors to come in and see. I'm also very excited to tell you the stories behind those consoles because it's really cool. Now, ladies and gentlemen, there were 7 original astronauts that first flew to space, not on space shuttle, back in the very earliest days, called the Mercury program in the early 1960s. One of those astronauts was very famous, the first American to ever orbit the Earth. That man's name was John Glenn. We have an artifact right here in our exhibit gallery that ties to John Glenn. The interesting thing is this: not only did John Glenn fly those very earliest space missions, he also went back to space aboard the space shuttle when he was 77 years old. Not a young guy at that time, but he's John Glenn, so he's cool like that and could fly to space when he's 77 years old. It turns out that the physical effects that astronauts face when they get to outer space are very similar to the effects of aging. So that's one of the reasons that they asked John to fly back to space, so they could do very careful medical testing of him in that orbit environment. Now, here's the fun part. When the space shuttle came down and landed, it had wheels that popped out, kind of like an aircraft does when it's coming down to a runway. And those wheels, well, some of them look kind of like a truck tire. In fact, a lot of them look like the wheel that we have sitting right over here in our exhibit gallery. You might see this tire. We're going to get a close-up shot right here. It just kind of looks a bit like a truck tire, but if you look very carefully, there's a skid mark on it right there. And there's a second skid mark on it right there. It turns out that that's not just an ordinary truck tire, folks. That is a space shuttle front tire that's actually flown to space twice and helped land the space shuttle on the runway 2 different times. Why do we know it's 2? Because we can see the skid marks. Plus, we also have the serial number of the tire, so we know which missions it flew. So the interesting thing about it is this: that front tire was actually on the Space Shuttle Atlantis when it flew, Space Shuttle Discovery, when it flew John Glenn back to the ground. So this was Discovery's front tire. And then the reason I said the wrong name is because they moved these parts around from different shuttles. And so Discovery was the mission where it came back down with John Glenn. So you can come to the Space Science Center and you can look at this tire and you can see that skid mark right there. And that is John Glenn's skid mark for when that hero of the American space program landed back on the Earth. Now, for those of you who are curious, that tire is not like an ordinary truck tire. When you put air in your tire of your car, you're pumping it up to somewhere between 30 pounds per square inch, 35 pounds per square inch, something like that. That tire right there held 300 pounds per square inch. And they didn't just use air, they filled it up with nitrogen. If you were to reach inside, you would find out that tire is very thick on the inside to handle all of that air pressure. So there's a really cool artifact from that particular episode in the history of our space program when John Glenn, 77 years old, still the oldest person ever to have gone to space, flew aboard America's space shuttle. All right, so one of the questions that we get a lot here at Space Science Center is, how do they go to the bathroom in space? Well, I'm not going to spend a lot of time on this, but I think I have an artifact here which can help us to understand how that works. Remember, in space, you're flying around in a state called weightlessness or microgravity. And so if you don't really have the effects of gravity, things don't fall down. If you were going to go to the bathroom, you might want things to fall down, not float up. So, in space, that's a bit of a tricky problem. But guess what we happen to have here? We have, well, it's sort of a space toilet. We're going to take a look at our space toilet over here. Now, this toilet right here actually flew aboard the aircraft that transported the space shuttle across the country. So the toilet itself has never been to space before. But it does work on the same principle as the actual toilets of the space shuttle, which is, in a word, vacuum. This is a vacuum toilet. Imagine a very powerful vacuum cleaner stuck to the bottom of that toilet. So if things weren't just kind of wanting to fall down on their own, well, you fire up the vacuum and that pulls it on down. That's exactly what happens with the astronauts in outer space. If they were to just let certain materials go on their own, they might float around the inside of the spacecraft. And that wouldn't be all that helpful. However, because of those strong vacuums and the fittings that fit on their bodies, they're able to pull all those waste materials into a safe place, shall we say. And then they store those materials that come in bags in a spacecraft and they return them to the ground, or in the case of the space shuttle, it just came back down with that spacecraft. So that's how that particular bodily function, we call it a bio brake. That's how it works in microgravity. The key word is vacuum, all right? All right, well now I want to get to one of our most important artifacts in the gallery, which is an amazing artifact. It's right over here to my right-hand side, your left-hand side as you're looking at the screen. We're gonna walk over here. Ladies and gentlemen, I want to show you this. It's a big artifact. It's a legend of the American space program, because that, ladies and gentlemen, is a component of the space shuttle's main engine. The main engines of the space shuttle generated 12 million horsepower. Let me say that again. A NASCAR goes around the track really fast. It has about 850 horsepower. This is a 12 million horsepower engine. Space shuttle had 3 of those engines, so a total of 36 million horsepower, all on the back of the space shuttle right there. You can see these little nozzles on my model. Well, that's the scale, but that's the real thing back there behind me. Now, that orange tank we were talking about, it was full of fuel, but I didn't tell you what kind of fuel. That fuel was liquid oxygen, which is a weird substance. Yeah, how do you get oxygen to be a liquid? You have to make it almost as cold as absolute zero. Almost as cold as anything on Earth can be. So, liquid oxygen and liquid hydrogen. Do you know what you can make when you combine hydrogen with oxygen? You might have figured it out. H2O. Water, right? You can mix hydrogen with oxygen and create water. Well, it turns out the reaction, the chemical reaction that forms that water, it actually gives off some energy. So those substances really want to be in that state, so they let go of some energy so they can be combined like that into that water molecule. So if you combine enough hydrogen with enough oxygen, you get energy out. You actually get an explosion. That's what took place in an engine that was strapped right to the back of this nozzle. Hydrogen combining with oxygen, creating water, but also creating a whole lot of energy. And when I say a whole lot of energy, I'm talking about 12 million horsepower worth of energy. The massive engine was connected right here. The interesting thing is this. The gases that were formed in the chamber of that engine, that were coming out through that nozzle, they were half the temperature of the surface of the sun. Ladies and gentlemen, this engine back here was a fire-breathing dragon. The gases coming out of there would melt this metal. In fact, it would vaporize it. The metal wouldn't even have a chance to catch on fire. It would simply turn to a vapor because that gas is so hot. So the question is, this nozzle, if it ever had an engine attached to it, how did it survive? Well, not only did it have engines attached to it, this nozzle's been to outer space 9 different times. It flew on 4 of America's 5 space shuttles. The only one it didn't fly on was Challenger, and that's because it came into service with the replacement for the Challenger space shuttle, which was called Endeavour. That was the first space shuttle that this ever flew on. But how did it survive? Well, here's the answer to that question. It turns out if you look very carefully at this nozzle, and I'm going to have Wanja walk up and she's going to show you the cutaway right there. You can see that piece of the nozzle that's cut away. You might be able to see some little tiny holes in the metal right there. That's because the skin of this nozzle is entirely made out of pipes. There are 1,080 little pipes that are all configured together to make the skin of this nozzle. Those pipes have to be made with such precision to create the exact perfect shape that master craftsmen have to take all kinds of time in order to braze all that metal together to get it to follow that behavior. But then they circulate that super cold fuel. Do you remember the liquid oxygen that we were talking about? They circulate that super cold fuel right through the skin of that nozzle. And so it does two jobs. Number one, it keeps the nozzle from melting. You need the shape of the nozzle to help push the rocket to space. But number two, it also warmed up that fuel, that super cold fuel, before it went into that hot engine chamber, so it didn't cause the engine chamber to explode or to shatter. Man, that's genius, right? Accomplishing those two very important jobs just by running that fuel through the skin of this nozzle? No, folks, that's not called genius. That's called engineering. And I know there's a lot of you out there who are paying attention right now who knew a lot of the answers to these questions already that I've been talking about. You're going to be America's future engineers. We're happy to help you along that journey right here at Space Science Center. By the way, if you like Star Trek, if you ever heard of Star Trek, Gene Roddenberry's ashes actually flew to space on one of the missions that nozzle helped fly a space shuttle to outer space. So that's a really cool fact too. Part of Star Trek's history is also tied up in this nozzle right here. All right, I have just a few more things I want to show you on this tour. Come on down there here with me. We're going to show you some things that are even older than the space shuttle program. We had a very exceptional opportunity. There's a man who lives in our town whose brother went to the moon. That man's name is Tom Scott. Tom Scott, a very good friend of ours, has worked at the Columbus Chamber of Commerce for a long time, came down one day and said, Dr. Cruzen, my name's Tom Scott, and my brother Dave flew on Apollo 15 to the moon. I said, yes, sir, I know who Dave is. Dave Scott was the commander of Apollo 15 and one of only 12 people to ever walk on the surface of the moon. Mr. Scott says, Dr. Cruzen, how would you like it if I lent you some things from my collection from my brother's trip to the moon? Well, what did I say? Absolutely, sir. We would love to put those on display. Well, later on, Mr. Scott allowed us to keep those, and he's since given us even more artifacts, and they are in some of these cases that you see right behind us here on this wall. I want to show you a few of those. Come on over here with me. Let's get a close look. Let's focus on that photograph of Dave Scott right there. Ladies and gentlemen, that's a picture of Dave Scott, commander of Apollo 15, around the time that he went to the moon. And right next to that picture is another picture of him actually standing on the moon. And folks, you can see that those photographs are autographed. So they're original signatures from Dave Scott. Now, just above the picture that he's standing on the moon is a patch. There it is. That's the patch I want to show you. Folks, that patch is very, very special because Commander Scott took that patch with him to the surface of the moon, brought it back home, and it is now on display here at the Coca-Cola Space Science Center. That is one of my favorite pieces in the entire exhibit gallery. Even though it's quite simple, that history is just so amazing. Now let me tell you something very special about Commander Scott. He was not the first person to walk on the moon, but Commander Scott was the first person to ever drive a car on the surface of the moon. Let me show you what that car looked like. I know it was not red, but this is a 3D printed model that we printed here at Space Science Center of the Lunar Rover. And you can see it has 2 seats, it has a radio antenna to communicate, it has a video camera so they could send pictures of where they were driving back to Earth. It's got a joystick right there, that's how they controlled it. These wheels were made of something that was kind of like piano wire. So they weren't tires that were inflated with air. It was like piano wire. And so this whole car could fold up underneath their spacecraft, and when they got to the moon, it could unfold and turn into this car. They drove this car a long way, several miles across the surface of the moon. They were the first ones to ever get more than walking distance away from their spacecraft, which quite honestly was a very dangerous thing. What if this car broke down? You can't call a tow truck. There's no AAA up there on the moon, right? So they had to make sure that they could get back to their spacecraft. So they drove, but then they came back, and they drove a different direction and came back. They always stayed within a distance where they knew they could make it back walking if they needed to. Now the last thing I want to show you is this. Before they could ever get to the moon, they had to launch on a very, very large rocket. That rocket was called the Saturn V. As you can see just by looking at this model, it looks very different than our space shuttle that I was showing you before. It looks like a giant long stick. Well, for another thing, this rocket was much, much larger than the space shuttle. All the astronauts and all their equipment and all their gear was right up here at the top. The rest of this rocket was all full of fuel and engines. And ladies and gentlemen, it was not small. This rocket was 363 feet high. It was as tall as a 36-story building. I want to give you an idea about what that would look like. If I held it up next to the Affleck building. I hope you can see that picture well enough. This rocket would have been taller than that building here in town that has the duck on the side of it. By quite a lot, actually. So you have to be a very brave person to get aboard that rocket. Now, when people ask me, and this is one of our questions, how do we know that we ever went to the moon? When people ask me that question, I say this. There were over 1 million people that watched that rocket launch every time it launched people to the moon, lined up along the beaches in Florida. Ladies and gentlemen, that was the most difficult part of our journeys to the moon. It was that trip aboard the rocket. So all those people were witnesses. That's how I know, among many other things, that we actually went to the moon. Okay? Well, we have just a few minutes for your questions now. I'm going to answer a few of the questions we have here, and we're going to go back over here to answer those questions.
All right.
Hope you enjoyed seeing those artifacts. And I know we got some great questions. We're going to get those answered for you. All right, it's a little bit lighter over here, a little bit brighter. So we're going to take the questions now. And what questions do we have from our audience, Wanja? By the way, with me today is Wanja Goge. She's the assistant director here at Space Science Center. She's behind the camera. She's going to be asking the questions.
They got a shot of me because I accidentally flipped the camera a couple minutes ago.
You saw her. She's got her fancy glasses on today.
Sure, I might ask my questions live. So we've got a couple questions for you.
Right.
And Jill wants to know what's a favorite space food for astronauts?
Oh my gosh. A favorite space food. Look, they really like anything that they can eat easily and that makes them feel like home, right? So I'm sure that different astronauts have different favorites, but one of the things that flew recently up on the International Space Station was actually a cappuccino machine. So you can believe that when they finally got that beautiful smell of fresh coffee up there on the International Space Station, all those astronauts were very happy about that one. I can tell you the one they don't like, seafood gumbo. That's right over here in our display case, because they didn't really want to take it. It kind of smelled bad. Next question.
All right. This is from a third grader, and they want to know, what do you think astronauts miss the most that they didn't expect to miss when they go up to space?
That's a very good question. Now, I'm not an astronaut. I've never been to space, but I have heard the astronauts answer this question. And you know what they miss? They miss green. They miss seeing green plants. There's no greenery really in space. They are trying to grow some plants in space now, but for the most part, during the history of the space program, we didn't really have a lot of plants up there. And that's one of the things that they just miss is fresh air, green grass. Those are two really important things. And of course, they always miss their family and want to get back to them as soon as they can.
All right. Amy's daughter Harper wants to know, why do astronauts even go into space?
Oh, why do we go to space? Listen, I can't answer that question for every astronaut, but we all, in our hearts, have a desire to explore. We want to find new things. We want to make discoveries. And space is one of those places where there are just all kinds of discoveries waiting to be had. But the astronauts aboard the International Space Station right now, they're doing all kinds of biomedical research, helping to work for cures and medicines that help with cancer, help with the effects of aging. They're also seeing if we can live in space for long periods of time, so that someday maybe we'll go and colonize the planet Mars. There are a long list of reasons to go to outer space. Those are just a few.
Okay. Luke wanted to know what type of fuel was used by the space shuttles. I think you covered that, but is the same fuel type going to be used in the newer rockets?
That's a great question. Fantastic follow-up question. So the question was, what kind of fuel did the shuttle use? Remember, that was that liquid hydrogen, liquid oxygen combination. That's what space shuttle used in its main engines. Then the follow-up question was, is that what they're going to be using in the new rocket, which is the Space Launch System? Well, guess what? This is really cool. The answer to this question is very cool because they're going to use the same engines. Like the same kind of engine that we have in our gallery, that's what NASA is using on its new rocket to take astronauts to the moon. So we're very proud to have that engine sitting here, not just because it was part of the space shuttle program, but also because it's going to be part of NASA's new moon rocket. Yes, using the same kind of fuels, liquid hydrogen, liquid oxygen. What's coming out of those engines? It's water vapor.
All right. The last question for now is, has a Rubik's Cube ever gone into space? Do you know?
A Rubik's Cube. So Rubik's Cubes, I don't know if I can answer that question specifically. I can't imagine them spending long periods of time in space without one. I'd have to check my NASA history sources to find out if Rubik's Cubes had ever gone to space. But let me give you, in closing, just a couple of words of advice from some of our astronaut friends. You know, I know that many of you now you're bound in your house, you're having to stay close to home, you can't go to school, can't go to work. The astronauts wanted me to share a few things with you. They put these messages out on the internet. And a couple of things. Number one, from Scott Kelly, who's the twin brother of Mark Kelly. Scott spent a year aboard the space station. He said this. He said, not everything we do in space is rocket science, but when it is rocket science, we ask a rocket scientist. In other words, pay a lot of attention to what the experts are telling you because they spent all of their time studying those subjects in detail. So make sure you're listening to what the experts are telling you about washing your hands, about all the things that we need to do to be very careful about this virus. Not rocket science, but when it is rocket science, ask a rocket scientist, or in other words, trust that expert. Here's another great quote from Anne McClain. Anne McClain says, in times of uncertainty like this, you have to get your expectations back in line, right? The problem is, so many times we're unhappy because our expectations are not meeting up with reality. Well, reality is what it is, and you can't change it. She said, expect to do things differently. Expect to be out of your comfort zone, because you will be out of your comfort zone. And expect to try to reach out and help others. I thought these were very wise words from an astronaut who'd been aboard the International Space Station and has also been right here at the Space Science Center. One last thing from Buzz Aldrin, second man to walk on the moon. Buzz says, I'm going to keep my door locked and I'm going to be laying on my backside. That's what he said, on my backside. So maybe that's what we should all do. We should all stay close to home. Make sure you're taking precautions to keep yourself healthy. I hope every one of you stays healthy, stays safe. When this is all over, please come back down and hang out with us at the Space Science Center because we really miss all of you. See you, everybody. Thank you.